Welcome to our today's lesson. We are to continue in the empirical formula, and today we are looking into empirical formula, and today we are focusing on the calculation of empirical formula from percentage composition. We have to calculate, remember in the previous videos we'll be looking at how do you find the empirical formula, and also how do you find the empirical formula of a molecular from a molecular formula. But now you have to use the empirical formula to find the percentage composition. All right, let's look at this question, a Cambridge question, which says an oxide of sulfur contains. An oxide of sulfur contains. Let's copy the question. An oxide of sulfur, so that's what sulfur oxide contains. It contains 40% sulfur and 60% oxygen. So let's write it in a different marker. 40%, that's sulfur, and 60%, that's oxygen. So there is more oxygen content in this oxide. All right. So the question continues and say, find the empirical formula. So this is the composition by mass, and we want to find the empirical formula. Find the empirical formula. So remember the other time when you want to find the empirical formula, we'll look at the molecular mass and also divide it into the mass given, and then at the end we'll divide with the smallest number of moles, and we'll get the empirical formula. So that's the same method. The only thing that changes is the percentage only. So the first thing is we are going to write the percentages, right? So we are going to convert the percentages into grams, because you know 40% is the same as 40 grams. So the calculation follows. So let's consider our 40% as 40 grams. And then consider our 60% as 60 grams. Right, so the next thing we look at the relative molar mass of sulfur, which is 32. Sulfur is 32. We divide by 32, remember. Also divide here by the molar mass of oxygen, which is 16. Let's take our calculator. By so doing, we end up having 1.25 moles, and 16 into 60 we'll get 3.75 moles. 3.75 moles. Right, so remember we said we divide with the smallest number of moles, so we are going to divide with 1.25. 1.25, also here 1.25. Let's take our calculator again. We know this will give us 1 ratio, and 1.25 into 3.75 will get 3. So this is the empirical formula. The empirical formula now is in the ratio 1:3. So we can write it as sulfur is in this form. Sulfur is 1 and oxygen is 3. So how do we write our sulfur oxide? We are going to write it in the form 1:3. Remember it was sulfur which was 1, so we don't write anything, but oxygen is 3. So this is the empirical formula. Right, thank you very much. We'll move on from here now. We want to look into the next part. We are done with the empirical formula. Let's continue with our lesson. Today we also want to look into two commonly used terms in calculation. They are commonly used, but they are also commonly misused as well, because many students, they don't really know the differences between the two. So this is why we have to get to there. We want to know how to calculate the relative molecular mass of a molecule, and also how to find the relative formula mass. So two things that we want to compare: relative molecular mass. So this has nothing to do with empirical formula now. We are still in calculations. Now, we also want to find the relative formula, mass. They are all masses, but one is the molecular and the other one is the formula. So these two are correctly misinterpreted. They are different, as you can see from the words themselves. So firstly, let's look into how do you calculate the relative molecular mass. So there's a formula that is used in calculating the relative molecular mass. The relative molecular mass can be found as the average mass of molecule of a substance. Relative molecular mass is equal to average mass over 1/12 of carbon 12. 1/12 carbon 12. Right, so this is the formula that we use in finding the molecular mass. All right, so there was a question which I still remember, which says, what is the relative molecular mass of carbon dioxide, right, and also of sucrose? I still remember this question. And many students, they couldn't calculate the relative molecular mass of carbon dioxide, but I'm going to show you how simple it is to find the relative molecular mass of carbon dioxide. Okay, so we'll write carbon dioxide for A, the first calculation, carbon dioxide CO2. So to find the relative molecular mass, we are going to say MR is equal to carbon. Carbon has got a mass of 12. 24 is 612, so the mass is 12, the atomic mass of 12, plus the one for oxygen. Oxygen, it has a mass of 16, so we say 2 times 16. 2 times 16. Why? Because there are 2 moles of oxygen. So here, if you take our calculator and punch, we'll see that the MR for carbon dioxide is 44. So that is the answer. As simple as that. So hence the relative molecular mass of carbon dioxide is 44. Right? We just leave it as 44. Don't put grams, just leave it as 44. Let's move on to the next part. The next part is part B. We are still on the relative molecular mass. Part B now says, how do you find, it says, I remember it was about sucrose. Yes, calculate sucrose. What is the MR of sucrose? So this one, very few students got it correct. Why? Because most of them, they confuse the chemical name for sucrose and carbohydrates. So I'm going to show you the difference. Carbohydrates, is the one that is C6H12O6. But sucrose is not carbohydrates. We know sucrose makes carbohydrates. Sucrose, we are talking of a substance that is not yet digested, like sugar. The sugar that we take at home is what we call sucrose in labs. So sucrose is C12. C12, H22 and O11. C12, H22 and O11. This is sucrose. So you should remember the difference between sucrose and carbohydrates. Carbohydrates, we're talking of starch or sugars that are now digested, that's biology, and they will form energy-giving foods, which we call carbohydrates. But sucrose is undigested carbohydrates, which we use almost every day at home, all right, as sugar. So let's use the correct chemical name. So sucrose is the one that I've said, MR of sucrose, MR with the small letter R, it's not Mr. MR of sucrose, C12, remember, H22 or 11. All right, so we multiply. 12 multiplied by 12 plus hydrogen is 1 times 22, then oxygen 16 multiplied by 11. So at the end we are going to get what? Let's punch on the calculator. The final answer is 342. So this is the MR of sucrose. Alright, so I've shown you two examples on how to find the relative molecular mass. Let's move on to the formula mass now. How do you find the relative formula mass? Alright, so it's almost the same thing, but this time we are given a formula. Let's define the relative molecular mass. The relative molecular mass of a compound is found by adding up the relative masses of atoms in the formula. That's what it means. For example, we can have, what is the relative formula mass of magnesium sulfate? Okay, so relative formula mass of magnesium sulfate. Magnesium sulfate, MgSO4, and we have a 2 here, cancel, so we have MgSO4. That's magnesium sulfate. So if you are not in a position to recall the chemical name, and if the exam comes with a question like, say, it doesn't give you the chemical name, then you are in trouble. You have to know how to write chemical names like magnesium sulfate. So the same way that we calculated the molecular mass is the same way that we're going to calculate the formula mass. The difference is that this is a formula, it's not a molecule. Alright? This is a formula, it's not a molecule. So this one now is the formula of magnesium sulfate, and we can say magnesium is 24 and sulfur is 32 and oxygen 16 times 4. Let's punch on our calculator and find the value. Okay, the final answer 120. So 120 becomes the final answer. So the formula mass of magnesium sulfate is equal to 120. So this is the formula mass. Okay, so that's how we get the answer. So the calculation is the same, but we have to know that they are different things. The relative formula mass and also the molecular mass, they are different. All right, thank you for joining. We'll see you in next lessons.